Hello students, and welcome to this video. We're continuing to learn about conic sections, and one thing to note is that all conic sections have what we call a locus of points relationship. So if we look at circles, so here's my nice circle and a center, and we know that a circle is a locus or set of points with a certain characteristic that every single point on the circle is the same distance from the center. We call that the radius. So it's a locus or set of points with that distance relationship. And a parabola also has a locus of points relationship. So you might remember from when we studied parabolas in chapter 2 that we said that we have a vertex, of course, but we also have a focus. And the point and distance relationship is that, if I draw in my directrix here, the distance from the focus to any point on the parabola equals the distance from that point on the parabola to the directrix. And we would make that a perpendicular line to the directrix. Clearly, I did not draw my parabola to scale for this particular set of information, but here again another example. Distance from focus to a point on the parabola equals distance from that point to the directrix. I would have needed to make a much wider parabola for it to look right in my picture. Okay, so today we're going to be looking at parabolas, and I'm not sure exactly what notes number this is for you, but you can figure it out and fill that in, and the date as well. So this is a review from section 2.3, notes number 9, way earlier in the year. And at the time, we called standard form for a parabola, or for a quadratic equation, y equals ax squared plus bx plus c. And at the time, what we called vertex form looked like this. Y equals a times x minus h quantity squared plus k, where the vertex was hk. Now, don't forget, we also learned about parabolas that open right and left, and in that case, we had the equation x equals a times y minus k squared plus h. So we used those names at the time, standard form and vertex form, or we might have even said general form for the first one. Now, when we talk about conic sections, we have vocabulary, standard form, and general form, as you saw for circles. And so for conic section vocabulary, when we say standard form, we're going to be referring to what we used to call vertex form. So if it opens up or down, it's y equals a times x minus h quantity squared plus k. Or, in some cases, we subtract k from both sides and we write y minus k equals a times x minus h squared. That's kind of nice because you can see the change in y, the vertical shift up or down, and the change in x, the horizontal shift left or right. It's kind of consistent that way. Or if it's a parabola that opens right or left, we have, for our standard form, x equals a times y minus k squared plus h. Or if we subtract h from both sides, we have x minus h equals a times y minus k quantity squared. So we'll be referring to those as standard form. It doesn't really matter to me whether you put the x by itself or have the x minus h form. And you'll notice when we do assignments that some of them are written by other people and some of them use variations on these forms as well. And then for general form, just like all conics, we still have some x squared term, some y squared term, some x term, some y term, some constant, and equal 0, where the coefficients are integers, the order of the terms matters, we have the equal 0. However, for a parabola, you're not going to have both x squared and y squared, you'll have one or the other. And we've also seen where you might not have an x term, you might not have a y term, so that's fine. Okay, let's review what we learned about the relationship between a focus, a vertex, and a directrix. So let's take the parabola that opens up or down. Y equals a times x minus h quantity squared plus k. Remember, the vertex is HK. And making a little sketch here. The focus we'll put right there. And the directrix we'll put right here. It's a horizontal line in this case. And we had this value that we called P. And the absolute value of P was the distance from the vertex to the focus. I'll call that distance from V to F. And it's also the distance from the vertex to the directrix. Distance V to directrix. And A is 1 over 4P. So we learned that back in chapter 2. And if it happens to be a parabola that opens left or right instead, then we have x equals a times y minus k, quantity squared, plus h. Still, the vertex is hk. And still, the absolute value of p is going to be the distance from the vertex to the focus, or the distance from the vertex to the directrix. Let's make one that opens to the right. So here we have the vertex, here we have the focus. The directrix would be a vertical line, and so we have P, P, and we still have A equals 1 over 4P. Remember, if we go back to the up and down parabola, if A is greater than 0, it opens up. So that means if P is greater than 0, it opens up. If P is less than 0, it opens down. And for the one that opens right or left, if A is greater than 0, it opens right. So if P is greater than 0, it opens right. And if P is less than 0, it opens left. All right, let's work through some examples. And remember, you can pause at any time if you need to pause to write something down, or if you need to slow the video down to think, or whatever, it's fine. Number 1, a parabola has focus 0, 4 and vertex 0, 1. Find the equation of the parabola in standard form and general form. Okay, so let's make a sketch. Focus 0, 4. Vertex 0, 1. That information alone tells us that this is going to open up. And that tells us that our equation is going to be the form y equals a times x minus h quantity squared plus k. And we can tell the distance from the vertex to the focus is 3. So p equals 3. And a is 1 over 4p. So that's 1 over 4 times 3. So that's 1/12. And we know h and k from the coordinates of the vertex. So let's put all those numbers in, and we get y equals 1/12 times x minus 0 squared plus 1, since our vertex was 0, 1. Let's write that as y equals 1/12 x squared plus 1. You could also write y minus 1 equals 1/12 x squared. So we have our standard form. Now let's convert it to general form. Okay, so in general form, we're not supposed to have any fractions. So let's say I take y minus 1 equals 1/12 x squared and multiply both sides by 12. We get 12y minus 12 equals x squared. Now we have all integer coefficients. And it's up to you if you want to move all the terms to the right or to the left. If I move all the terms to the right, we have our x squared. We're going to subtract our 12y squared, and we're going to add our 12. So 0 equals x squared minus 12y plus 12. There's our general form. Okay, let's take a look at number 2. A parabola has focus -2, 3, and directrix x equals 4. Find the equation of the parabola in standard form and general form. So once again, let's sketch this. -2, 3 is the focus. The directrix is x equals 4. Vertical line. So we already know that this is a parabola that's opening to the left. Something like that. Maybe I'll wait and draw that after I find my vertex. So let's see. The distance from the focus to the directrix is 6. So halfway in between those points, we should find our vertex. So the vertex is at 1, 3, the same height as the focus. Okay, now we also know that the value of P is -3. Negative because this is opening left, and 3 because that would be the distance from the focus to the vertex. So now that we have that, we can get A, 1 over 4P, and that will be -1/12. And because it opens to the left, we're going to use the form x equals A times y minus k squared plus h. So putting our numbers in there, we have x equals -1/12 times y minus 3 squared plus 1. Or if we prefer, we can subtract the 1 from both sides, and we have x minus 1 equals -1/12 times y minus 3 squared. That's our standard form. You're going to notice when you do the homework today and or the practice problems next time that the person who wrote that worksheet and that answer key might write things a little bit differently and write something like -12 times x minus 1 equals y minus 3 squared. So that's just a variation on the form. No big deal. But if I ask for standard form, be sure to give me one of these two. Okay, now let's find the general form. Let me take what I just wrote, since I already kind of started getting rid of the fractions. Distribute the -12, and we have -12x plus 12 equals, and then we're going to FOIL on the other side, y squared minus 6y plus 9. And then let's decide what side we want everything to go on. So might as well just move it to the right. That way we get to lead with a positive, which is always kind of nice. So we have 0 equals y squared plus 12x minus 6y, and then we're subtracting 12 from both sides, so minus 3. And there's our general form. This low box. Okay, let's take a look at the next one. Number 3. A parabola has general form equation 2y squared minus x minus 20y plus 48 equals 0. Convert the equation to standard form and graph the parabola. Okay, so we're going to have to do some completing the square. So let me put my -x term first, and then the 2y squared, and then the minus 20y. And I'm going to subtract 48 from both sides. Okay, so when we were working with the circle and we had to complete the square, we were able to divide everything by whatever coefficient was in front of the square terms. But I don't think in this case we want to divide everything by 2. But here's what we can do instead. We can factor out the 2. So factor the 2 out of the y squared term and the y term. Then you can complete the square. Okay, so what number completes the square? We take half of -10, which is -5, and square it, and we get 25. So 25 completes the square. But we didn't really add 25. We added 25 times 2. We added 50. So to the other side, let's add 50. Okay, so now we can write this as negative x plus 2 times the quantity y minus 5 squared equals 2. So remember what we're doing is converting this to standard form. And we can see that it's going to be an x equals y squared kind of equation. So I'm going to subtract some terms to get them to the other side. And we have negative x equals negative 2 times y minus 5 squared plus 2. Or we could go ahead and multiply both sides by negative 1. So we get x equals 2 times y minus 5 quantity squared minus 2. That looks like standard form. Or if we want, we can write x plus 2 equals 2 times y minus 5 quantity squared. So we have our standard form. And don't forget, it also says to graph. So let's gather some information in order to graph. What's the vertex? So what's h and what's k? Looks like the number we subtracted from x is negative 2, and the number we subtracted from y is 5. So we get negative 2, 5 for the vertex. We know it opens to the right or left since it's x equals, and because we have a positive value for a, we know it opens right. So we can start our sketch. Negative 2, 5. Vertex. Okay, let's find the value of p. So a is 2. And a equals 1 over 4p. So if we multiply both sides by 4p and then divide by 8, we get p is 1/8. Okay, so depending on how small your graph is, this could be a little tricky. But we're going to go 1/8 of a unit to the right of the vertex to get to the focus, and 1/8 of a unit to the left to get to the directrix. So to get the coordinates of the focus, we are going to add 1/8 of a unit to our vertex x coordinate. So that gives us negative 1 7/8, comma 5. And for the equation of the directrix, we're going to subtract 1/8 from negative 2. So we get x equals negative 2 and 1/8. Now it said graph the parabola, and so far all we have is one point, the vertex. And in order to know how wide to make this parabola, we should probably find a couple more specific points. So I'm going to look for the y-intercepts. So taking the equation and putting a 0 in for x to find the y-intercepts. It's going slow, folks. Okay, so we have 2 equals 2 times y minus 5 squared. Let's divide both sides by 2, and we have 1 equals y minus 5 squared. Let's square root both sides, and we have plus or minus 1 equals y minus 5. And then let's add 5 to both sides. So we have y equals 5 plus or minus 1, and that would be 6 or 4. So that means we have y-intercepts 0, 6 and 0, 4. Let's plot those points on our graph. And draw the parabola. I'll choose a different color. Another point you could choose to find is the x-intercept, although I suspect it's way out there and probably wouldn't fit if you only allotted yourself so much space for the graph. Okay, so that one is done. Bonus content. This is a doozy. There is something called a lattice rectum. Very strange term. So if you have a parabola Let's just make one that opens up. And here's its focus. And here's its directrix. You could find points on the parabola that are at the same height as the focus. And if you connected those points, you would get a chord that was parallel to the directrix. Chord through focus, parallel to directrix. That, my friends, is the segment that we call the lattice rectum. Interesting. I have not yet researched the practical use of that, but we know the focus of a parabola is very useful. So, example number 4. Use the parabola in example 1 and find the length of the lattice rectum. So let's go back to example 1. Y equals 1/12 x squared plus 1. And what did we know about it? Let's go back again. We see that the focus is 0, 4. And that's probably all we need from that to be able to answer this question. Well, that didn't work. Focus, 0, 4. Okay, so we're looking for the points that are also at a height of 4. If this is 0, 4, then what other points are at a height of 4? And those points have to fall on the parabola. So those points have a y-coordinate of 4. So why don't we take 4 as our y, plug it in, and solve for x. Let's subtract 1 from both sides. These numbers are working out nicely. Let's multiply both sides by 12. And let's square root. Okay, so we have the point -6, 4, and we have the point 6, 4. So what is the length of the lattice rectum? What is the length of that segment? It would be 12. 12 units of some kind. All right, very good. Thank you for watching and listening to this video and taking notes. And, for homework, we're doing the conic sections parabolas worksheet, and depending on whether in class we got to the term lattice rectum, the live class may have skipped 16 and 17, but if you made it to the end of the notes video, then you know what that is, so you can do all of them. Thanks, everybody.